Today I am going to be explaining Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, and objects in 1D and 2D motion. Let's start with Newton's first law. Newton's first law states that an object at rest will stay at rest unless acted upon by an unbalanced force, and that an object in motion will stay in motion at the same speed and direction unless acted upon by an unbalanced force. This is also known as the law of inertia. Let's use the basketball as an example. Here, the ball is at rest, which means it has balanced forces. There are two forces acting upon the ball at this moment. There is Fg, or gravity, pulling the ball down, and Fn, or normal force, pushing the ball up. These two forces have an Fnet of 0. When we say Fnet, we mean the sum of all forces. When I shoot the ball, my hand pushes the ball right using normal force at roughly a 70-degree angle. Normal force is a perpendicular force which acts upon two objects that are touching. This causes the ball, which was at rest, to accelerate into motion because it was acted upon by an unbalanced force. This brings us to Newton's third law, which states that a third law pair must be equal in magnitude, opposite in direction, and have the same type of force. When I shoot the basketball, I apply normal force in the rightward direction at a roughly 70-degree angle. According to Newton's third law, the ball pushed my hand back with the same magnitude at a 250-degree angle, also using normal force. The same can be said when the ball hits the ground. The ball and the ground are third law pairs, and therefore they are equal in magnitude, opposite in direction, and have the same type of force. This raises the question, why does the ball bounce upwards and the ground not move? This can be explained by Newton's second law of motion, which states that the force and acceleration of an object has a direct proportion, and the mass and acceleration of an object has an inverse proportion. In other words, Newton's second law states Fnet equals mass times acceleration. This basically means a more massive object requires greater force to accelerate it the same amount as a less massive object. The ground and the ball actually have the same amount of force acting on them, but the ball is affected more because it is less massive. Now to the motion of the basketball in 1D and 2D space. If we look at the movement of the ball as a y-velocity time graph, the line would start above the origin and would run with a negative slope through the origin and eventually negative. This is because the y-velocity of the ball starts positive, but slowly decreases until it reaches its apex, which is when the velocity is 0. Then the velocity grows more and more negative as the ball falls. An x-velocity time graph would start above the origin and be a straight line heading right. This is because the x-velocity of the ball is constant and positive throughout the entire video. If we were to represent the ball's movement in an x-position time graph, the line would begin at the origin and steadily rise. This is because the ball moves steadily forward on the x-axis during the video. If we were to represent the flight of the ball as a y-position time graph, the graph would look exactly like the flight of the ball. This is because the ball starts moving above the origin, then moves upwards, and finally falls to the origin.